Today we'll be doing algebraic vocabulary. You will need the following items: scissors, glue or tape, a pencil, and you may also want a highlighter. You can do this without one if you don't have access to one, but you may want one if you do. Get your supplies together and let's get going. Okay, you should have picked up the following two pieces of paper. You have a sheet that has algebraic vocabulary at the top, and you have this cut sheet over here. These all need to be cut apart. This needs to be taped into your interactive notebook. All right, while you're doing that, be sure and pause the video. Get yourself set up. We want to go ahead and tape it in our interactive notebook so that we don't lose it. And then we'll begin. Okay, we're going to start at the top of this thing. We're going to work ourselves down, gluing in the definition and writing an example or picture. So the first word we're going to deal with is variable. Now, based on our warm-up, you should know that a variable is a letter that stands in place or represents an unknown number. So find that piece and glue it in. When you were in kindergarten, this looked like a box. You would often have equations that had a box, or it became a line. Sometimes we put a question mark, but in algebra we use a letter. The most common letter we use is X. That's why we drop the multiplication sign. So when we're doing a variable, it has other things attached to it, and so we will be talking about those too. An example would be this expression right here. 3x plus 5. So in this expression, the letter x is representing the variable that we don't know. So right here is our variable x. We don't know what x is, but we have 3 of them, and then we can add 5 more to it. So that variable is what's representing an unknown quantity. There, I decided to bold my X a little bit so you can see this one is the one we're talking about. So these other pieces have names, and we'll be getting to that in a minute. We have an independent variable. A variable can be a different type, and this one is independent. You may be familiar with this from science, because an independent variable is the input value that causes change. So we know about this in terms of charts. What we put on the X side gets out with the Y, so we can write it and represent it like this. In this case, 3x is the input value. When we add 4 to it, we're going to get the output value. This is the independent. Whatever we have x of, we have 3 of it. So when we get to the dependent value, we're going to write this same equation right down here. So I went ahead and did the example. We wrote the same equation. This y is dependent on whatever x is. So this is our independent, this is our dependent. If x is 5, then this would be 19. If x is 2, then this would be 10. This y is dependent on whatever is going on over here. So we can say our definition is the value depends on another. It is the result. Again, this equal sign means equivalent. It does not mean solve, but it says whatever's on this side is equal to this side, but we don't know what that is until we solve this part. So here we have a big word right here. This is said coefficient. Coefficient. Try saying that softly to yourself. Coefficient. And a coefficient is a factor with the variable. So the definition that goes with coefficient is the factor with a variable, which it means multiply over here. So we're going to write our example. 3x plus 5. 3 is the coefficient. So if you look at the definition of coefficient, the factor, which is one piece of a multiplication with a variable, and in this case, that is x. So the factor is 3, the variable is x. 3 is our coefficient. Whatever x is, in this case, I have 3 of it. It could be 5, it could be 150, it could be 7 million. Your coefficient can be any number. It could be a fraction, all of that. It means whatever that number is, that's how many x I have of it. So our next word is constant. And one of the ways we know constant is that it's always there. And in math, it's a fixed value. So we can say that constant is a term without the variable. So we're going to write the same expression, 3x plus 5. So in 3x plus 5, we don't know what x is. That's not constant. It could be 4, it could be 0.5, it could be anything. Whatever it is, I have 3 of it. But 5 is always going to be 5, whether it's 5 kittens, 5 dogs, 5 homework assignments, 5 teachers. 5 is 5, okay? So it is a constant meaning. It is a fixed term that is not going to change. 5 is 5 is 5. It just depends on what you're talking you have 5 about, and that just comes from the word problem. So our next word is term. You're used to hearing like in terms of office or the terms of an agreement. Here we mean it in a math way. So this is what's called a multi-meaning word. The math definition is part of an expression can be what we call a term. So we need to get to define expression. If you notice, it's going to be a little bit further. But we can write the same expression here, and maybe I'll start picking up on what it is because I've used that word in almost every single one of these. So let's write 3x plus 5 again. All right, notice I haven't highlighted anything, all right? So this expression has 2 terms in it. I bet you can figure them out. Let's see. There's one, and here's the other one. So here's one term, here's another term. This term happens to have a coefficient and variable. This term happens to be a constant. Together, they create an expression. So I didn't highlight anything because it would be the whole thing. So let's talk about like terms. Like terms are terms that contain the same variable. So my example over here is going to switch up for just a little bit from our 3x plus 5. We're of course going to use that, but we're going to be adding to it. All right, so I gave you kind of a really long one. You have 3x plus 5x plus y plus 2. So when we're talking about like terms, we're looking for the things that are the same. So in this case, we have 2 things that are the same. We have 3x and 5x. They both have a coefficient. This one has 3, this one has 5. They both have an x. Can I include y in there? Is y the same thing as x? It's not. X, wherever x is, will have to be the same. If x is a number or kittens, this has to be kittens, this has to be kittens. Y is puppies, all right? So I can combine them. What is 3x plus 5x? If I combine the things that are similar, I would get 8x plus y plus 2. Now, you're not going to see a problem necessarily like this. We do get into x and y when we're doing a lot of our geometry. But with this, I just want to show the example that the 3x and the 5x both have an x. It doesn't always have to have a coefficient in front of it. If it's just x by itself, the value is 1 because I would just have 1x. So now we're getting to the point where you're going to define expressions and equations, and these two kind of go together. They're similar. They're very similar. There's a little bit of difference between the two of them. You've heard me use this before as we worked our way down, and one of the things you might notice is that it is called a math phrase. Just like in English, that phrase is kind of telling us what's going on. It's not a complete thought. It's not a complete sentence. So a math phrase would be something like, 3x plus 5. Okay, so before we talk more about it, let's talk about what an equation is. An equation is a complete math sentence with an equal sign. So you've heard us say write a math sentence before. That would be something like 3x plus 5 equals 20. That means that 20 is balanced out to this side over here. This expression is balanced with this expression. When I put them together with an equal sign, I have an equation. So if you notice up here when I have an expression, I don't have an equal sign. I'm not solving it. I'm not trying to figure things out. It could be any number I want to put in here. I could put 1 to 0.5, 85, whatever number. Since I have no information in that, I could put in that and I could get a solution. And here, this equal sign is telling me that these two sides are balanced. They are equal. They're just represented in two different ways. So this side is equal to 20. So to solve this side out, it would also have to equal to 20. That means I would have to discover what x is, that when I have 3 of them, and add 5 to it, it would equal 20. I wonder if you can figure out what that number would be. Anyway, that's it for today. You should have this in your interactive notebook. You should tape it down if you haven't already. And again, these are new terms. We're going to be talking about them. If you notice, your teachers have been talking about variables, and we have been using the word expressions or equations. It's just we really want to point out these definitions to you. All of 6th grade math is learning about algebra, and so we're taking all the stuff you've learned and putting it into algebraic terms so that your math career will be successful. So it is like learning a new language, and we're learning the language of algebra.